Okay, welcome back everyone. In this video we're going to do a quick example problem solving something with Coulomb's law. And so I'm going to do number 32 on page 531, which says that we have neighboring singly charged sodium and chlorine ions in crystals of table salt. So sodium chloride, so I have a sodium ion which is +1, and here I have a chlorine ion which is -1, and they are separated by a distance of 2.82 times 10 to the -10th meters. And so the question is, what is the attractive electric force between the ions? Okay, so that's Fe that we want to solve for. Okay, so we want to set up our basic equation that the electric force is K Q1 Q2 over R squared. Well, K is easy, 9 times 10 to the 9th newtons meters squared per coulomb squared, and I'm going to put in some of these units here, okay? But what about the charges? Well, what is the charge of an ion? Well, that just means that it has one extra electron, or it's missing an electron. So the charge of the ion, Q1, is actually +1e, where E is that elementary charge we talked about. So it's actually plus 1.6 times 10 to the -19th coulombs. Q2 is -1e, so it's just -1.6 times 10 to the -19th coulombs. So that means that I put each of those in here, and one shortcut that you can do to save space is to do 1.6. Well, let's not do that shortcut. Too many e's are confusing. 1.6 times 10 to the -19th coulombs, and -1.6 times 10 to the -19th coulombs. There, made it fit. Notice that those coulombs cancel with the coulomb squared and my constant. This is why it's important to keep track of our units. R is just 2.82 times 10 to the -10th meters, but now I'm going to square that. And when I do this calculation, I will get that it's -2.90 times 10 to the -9th newtons. Okay? And that's a pretty small force if you think about it. 10 to the -9th, and it's got a negative sign, which remember means that it is attractive. That's what that negative sign means. Okay? But something kind of fun that we could try is to think about this and to say, well, is this force really all that small? Don't these two objects have mass as well, m1 and m2? So do they attract each other because of the force of gravity? Well, sure. Well, how much is that force of gravity, just for fun? Well, the force of gravity is g m1 m2 over r squared. But now we have the problem of figuring out what these masses are. Okay, so now is the time when we bust out our periodic table and we look at sodium that has an atomic mass of about 23 atomic mass units, and chlorine has a mass of about, we'll just round it off to 35.5. Okay? And remember, not sure if you talked about this a lot in chemistry or if you know this, but this is mass units, so I'm putting a U in there. And 1 U is about 1.67 times 10 to the -27th kilograms. Okay? So to find the force of gravity, I'm going to do it this way, just for fun. 6.67 times 10 to the -11th Newton meter squared per kilogram squared. Okay, M1 is going to be 23 and M2 is going to be 35.5, but I'm going to take those U's and pull them out, and have u squared over r squared, 2.82 times 10 to the minus 10th meters, quantity squared. Okay, now u right here is 1.67 times 10 to the negative 27th kilograms. Okay, and so I invite you to check this, but let's see what we actually come up with. We have our 6.67 times 10 to the negative 11th times 23 times 35.5 times 1.67 10 to the negative 27th, but we have to do that twice. And then we divide that by r squared. And what I'm getting is 1.9 times 10 to the negative 42 newtons. Negative 42. Look at how tiny that force of gravity is, okay? When we go back to the electric force, that's 10 to the negative 9th. Alright, that's a factor. Well, we could say that the electric force is about 10 to the 33rd times as big as the force of gravity. That's important. That tells us that the electric force is really powerful, and gravity really has no role at all in the interaction between ions. It's all electric force. That's very important. Okay, so in the next video I'm going to show you a bit of an advanced way to figure out the direction of force.